This lesson is going to be about simplifying rational expressions, and we're going to do that in 3 ways in this tutorial. First, we're going to take a look at a normal everyday rational expression, one that you should already be familiar with, which is just a simple fraction. This fraction will be something along the lines of 12 over 32. So a number over a number. Remember that any number that takes the form some number divided by a number is a different number, or even the same number, is a rational expression. And here we have 2 whole numbers, one dividing into the one on the bottom dividing into the one on the top. When we're done with that, we are going to look at another expression that's going to be a little bit more complex. It's still the same thing. It's still one number. In this case, we'll use 7x to the 3rd power, and we'll divide that by x squared. And then for our third rational expression that we're going to simplify, we are going to take an even more complex number, not complex in terms of real versus complex, but complex in terms of difficulty of understanding. So we'll take an even more interesting number, we'll call it, I prefer interesting rather than complex anyway, and we will simplify that one. So let's take a look at the first one here. This one you're used to doing. You've done this before. You've called this reducing. You know that when you reduce, all you do is you take a look for common factors of the numerator and the denominator here. So what are common factors of 12 and 4? And there's a couple of different ways to do it. If you'd like, we can do a tutorial on how to find common factors. But for now, let's just rely on our math skills, our multiplication ability, and we can know that both 12 and 32 are divisible by 4. And when I divide 12 by 4, I'm left with 3. So 4 times 3 is 12. And when I divide 32 by 4, I'm left with 8. So that 4 times 8, it gives me this 32 right here. Now what I have when I divide my fraction and when I set my fraction into 2 factors, what I have is on the left side here, I have a number over itself. And we know that any number over itself, whenever I have an a over an a, it is equal to 1. That's an identity. That's actually the identity property of multiplication. So these divide out to 1, and I'm left with 3 over 8. So the fraction 12 over 32 is equivalent to 3 over 8, and in fact 3 over 8 is the simplified form of 12 over 32. Now when we look at the next problem, we are doing essentially the same thing. Our goal here is to simplify this rational expression, this fraction, into its smallest terms, the same way we did up there. So our strategy is also the same. We need to find the greatest common factor between this numerator here and this denominator there. How do we do that? We factor the numerator, and if necessary, we'll factor the denominator. Now I know that I can see that x to the 3rd and x squared are going to be my common factors. On the top, in the numerator, we're gonna have a 7 there. There's nothing in the denominator to divide out. There's no common factor there. But when I factor out an x and I multiply it times x squared, recognize that x squared times x is equal to x to the 3rd. So I just essentially factored out an x squared. Now on the bottom, I don't need to factor out anything more because I've already got an x squared. Now by the identity property of multiplication, x squared over x squared is what? It's 1, correct. So these divide out, and we're left with only this part here. 7x. We're actually left with that over 1, but we can write it as 7x. And again, we have now simplified our rational expression into its lowest terms. Now let's take a look at the third expression that we have listed here. We have t squared minus 16 over t squared minus 8 plus 16. And these are should be pretty easy for us to tackle in terms of factoring. Let me ask the question, will our strategy for simplifying this rational expression be any different from simplifying this rational expression or that rational expression? And if you think that the answer is no, our strategy will not be any different, then you're absolutely correct. We will not do anything different. The only thing different is the kind of factoring we have to do. See, here we had numbers, so we could factor our numbers into common factors. Here we had variables, so we could factor our variables into common factors. Here we have expressions. We have expressions with terms, and these expressions happen to have very easily factorable factors. You should know these just by looking at them. Here we have the difference of two squares. T squared is a perfect square, and 16 is also a perfect square. So you should be able to recognize very quickly that the numerator factors as t minus 4, which is the square root, 4 is the square root of 16, times t plus 4. And we can check that by doing our first terms, t times t, gives us the t squared. Our last terms, negative 4 times positive 4, gives us the negative 16. And our middle terms are going to cancel out because negative 4t plus 4t is 0. That's the identity property of addition. We've seen the identity property of multiplication. This is the identity property of addition. 0 is an additive identity. Alright, that's enough of that. So let's take a look at the denominator now. In this case, the denominator is what looks to be a perfect square trinomial. How do I know that? Because the first term is a perfect square, the last term is a perfect square, and the middle term is 2a. This is going to be t plus 4 quantity squared. But we don't want to write it that way because we want to be able to factor this effectively. So let's undo that part, and we'll make this t plus 4 times t plus 4. Now, why would I want to write this out instead of just putting in t plus 4 quantity squared? If you thought, because I want to be able to divide by 1, if I wanted to find common factors and divide by 1, you're absolutely correct. Notice that I have a t plus 4 here and a t plus 4. And t plus 4 over t plus 4 is 1. So what am I left with? I am left with the quantity here. And we'll rewrite that to make it nice and clean. It is t minus 4 over t plus 4. And this now is our simplified form of the rational expression t squared minus 16 over t squared minus 8t plus 16. So that's how to simplify three different kinds of rational expressions. Here we use simplifying with just numbers. Here we simplified with variables with exponents, and here we had to factor trinomials and simplify them, which is a lot more fun. I hope you learned a little something from this lesson, and we'll see you in the next video.